So how we can represent the number of atom types present in a chemical substance is using a chemical formula. So chemical formulas are used to specify the number and type of atoms in a compound or in a molecule. In a chemical formula, the type of each atom is indicated using the atom symbol, which will be either 1 or 2 characters, and then the number of each type of atom is indicated using a subscript that comes after the atom's symbol. So here's an N2 molecule. This is an S2O2 molecule. This is an N2O4 molecule, and this is a C2H4 molecule. One of the conventions is that if there is only one of a given atom type, then we don't write in the one. We leave that just blank, and it's implied that there is one just by the presence of the atom's symbol. For a molecular compound, what the chemical formula represents is the number of atoms of each type in a molecule of that compound. For an ionic compound, those that are composed of those positive and negatively charged particles, the chemical formula gives the ratio of ions present in the compound, and that ratio always adds up to being 0 electrical charge overall. Some groups of atoms consistently occur together, and sometimes what we will do is put those groups of atoms in parentheses and then add a multiplier following the parentheses to indicate how many multiples of that group of atoms that we have. So here's the compound Al2, parentheses SO4, 3. And what this indicates is that we have 2 aluminum atoms, and then 3 times 1, 3 sulfur atoms, and then 3 times 4, 12 oxygen atoms. Here's another example where we have lead, C2H5, all multiplied by 4. So we have 1 lead, 4 times 2, 8 carbon atoms, 5 times 4, 20 hydrogen atoms. This one's a little more complex again because we have oxygen appearing in multiple places, but in this formula we have 10 calcium atoms, then we have 4 times 6 plus 2 times 1 oxygen atoms, so that's 24 plus another 2, that's 26 oxygen atoms. And then we've got 2 times 1, 2 hydrogen atoms, and we've also got 6 times 1, that gives me 6 phosphorus atoms. So that's how we write chemical formulas. The subscript appears after the symbol for the atom type, and that indicates the number of that type of atom. Occasionally we'll put a group of atoms in parentheses followed by a subscript, and that indicates that everything within the parentheses gets multiplied by that subscript. So what are atoms made of? Well, atoms are made of what we call subatomic particles, and these subatomic particles are of 3 types: protons, neutrons, and electrons. So electrons are a negatively charged particle. They have a charge of -1, and their mass is very, very small. In fact, they are effectively without mass. We give the electron the symbol E superscript and then a minus sign. Protons and neutrons are very heavy compared to electrons. Protons have a charge of +1 and a mass of about 1 atomic mass unit, where an atomic mass unit is 1.67 by 10 to the -24 grams. Neutrons have no electrical charge, and they're a tiny little bit heavier than protons. Neutrons are given the symbol just a lowercase n. In comparison, protons are given the symbol either just a lowercase p, or more commonly a p with a superscript plus sign. It's important to recognize that because protons and electrons have opposite electrical charge, these guys will attract one another. Protons and neutrons are found bound together in what is referred to as the nucleus of the atom. Because of this, protons and neutrons are often referred to as nucleons. The nucleus is really, really small, but it contains effectively all of the mass of the atom. The nucleus is positively charged because it contains protons, which have a positive charge, and neutrons, which have no electrical charge. The electrons are found outside the nucleus at a great distance from the nucleus. They kind of orbit the nucleus like planets orbiting the sun, and what keeps them in that orbit is the attraction between the negatively charged electrons and the positively charged protons. So Ernest Rutherford did some experiments, and we'll learn about those later on, and he was able to calculate the size of the atom and also the size of the nucleus. He found that the nucleus was very, very small and comprised only about 1/100,000th of the volume of the atom. And what this means is that the electrons are at a huge distance from the nucleus. So this is kind of cool because what it means is that most of all matter is empty space. Most of all matter is just simply the empty space between the nucleus of the atoms that it's made of and the surrounding electrons. As atoms have no electrical charge overall, they must contain the same number of protons as they do electrons. The number of protons in the nucleus of an atom, which is also the number of electrons that it contains, is given the symbol Z and is referred to as the atomic number. So the atomic number, or Z, is equal to the number of protons, which is also equal to the number of electrons. Z will always be a whole number. Atoms of a given type or element have the same atomic number. So every hydrogen atom has an atomic number of 1. Every helium atom has an atomic number of 2. The atomic number is another way of defining what the element is. So atoms are composed of 3 different subatomic particles. Electrons, which exist outside the nucleus, have little mass and are negatively charged. And then there are 2 heavier particles, protons and neutrons, both with a mass of about 1 atomic mass unit. Protons are positively charged. Neutrons have no electrical charge. The neutrons and the protons are found bound together in what is referred to as the nucleus of the atom. Electrons exist at a great distance from the nucleus of the atom, and they orbit the nucleus kind of like planets around the sun. What keeps them in that orbit is the attraction between the negative electrons and the positive protons. So the atomic number we've already talked about. We're now going to talk about a second number called the mass number. So the number of protons that we find in the nucleus of an atom is called its atomic number. We give it the symbol Z. Because atoms are electrically neutral, the number of protons will also be equal to the number of electrons. The sum of the number of neutrons and protons in an atom is called its mass number. It's given the symbol A. So the number of protons plus the number of neutrons equals A. Now, as protons and neutrons both have a mass of about 1 AMU, the mass number will be approximately equal to the mass of the atom in AMU. So just kind of recapping, the number of protons is equal to the atomic number, and this is also equal to the number of electrons. If we would like to calculate the number of neutrons, the quickest way of doing this is to take the mass number and subtract the atomic number. The mass number will always be greater than the atomic number. So I just remember this as big number minus small number gives me my neutrons. We have a way of writing the atomic symbol for an element to clearly illustrate the number of neutrons and protons that it contains. What we do is we write the element's symbol, and then before and above it we write the mass number, and then before and below it we write the atomic number. And you always just want to remember that the mass number is the big number and the atomic number is the smaller number. So if you keep that in mind, big over small, you'll do just great. So here are some examples. This is a hydrogen atom. It has 1 proton and a total of 2 particles in its nucleus. This is a lithium atom. It has 3 protons but a total of 7 particles in its nucleus. This is a sodium atom. It has 11 protons but a total of 23 particles in its nucleus. And here's a gold atom. It has 79 protons but a total of 197 particles in its nucleus. So what is a very important idea, we're going to come back to it again and again and again, is that when atoms interact with each other, it will be via their electrons. So they're going to interact via their outer surfaces. And so for this reason, it's the number of electrons in an atom, which is determined by its atomic number, that determines what the chemical properties of that atom will be. That is, that atoms with the same atomic number have exactly the same properties. Okay, so the atomic number of an atom indicates the number of protons it has. As atoms have the same number of protons and electrons, the atomic number also indicates the number of electrons an atom has. The mass number indicates the total number of particles that are in the nucleus of an atom, that is the neutrons and the protons, and will be approximately equal to the mass of the atom in AMU. The difference between the mass number and the atomic number gives the number of neutrons that an atom has. We can indicate clearly how many subatomic particles that an atom has using what we call the complete chemical symbol, where we include the mass number above and before the element symbol and the atomic number below and before the elements symbol.